Hello everyone, myself I am Pratibha. I am studying Bachelor of Engineering in Electronics and Communication Department at Sri Venkateshwara College of Engineering. I am here to discuss about civil engineering. In civil engineering, I am going to discuss about some important topics of civil engineering. Before going to the topic, I would like everyone to subscribe my channel. Let's go through the content. Scope of civil engineering, branches of civil engineering, different types of materials used in construction, types of concrete and structural elements for building components. First, what is the meaning of civil engineering? Civil engineering is the oldest, broadest, and simple of the various engineering fields. It is mainly related to planning, analysis, designing, construction, and maintenance of buildings, roads, bridges, dams, and others by the use of physical laws and mathematical equations. Let us see what are the scopes of civil engineering: surveying, structural engineering, geotechnical engineering, hydraulics and water engineering, transportation engineering, environmental engineering, construction planning and project management, earthquake engineering, and remote sensing GIS. Let us see what is surveying. It is the science or art of map making. It mainly deals with various types of measurements and plotting of maps. Unless maps are drawn, no development work and construction can be undertaken. Modern instruments are distance meter, total stations, theodolite, etc. Modern technologies are photogrammetry and remote sensing have a mode of surveying. Building materials. The materials used for construction of any structures are called as building materials. Shelter is the basic need for every human being. The important factors considered while selecting materials are durability, strength, acceptance, cost, availability, and labor requirements. Building materials are mainly divided into natural, like sand, stone, timber, etc. Second one, artificial means man-made, bricks, cement, concrete, flooring or roofing tiles, steel, glasses. Concrete, it is a mixture of fine aggregates like river sand, coarse aggregate like jellies and cement. Fine aggregates, each particle size less than 4.75 millimeter is sieve. Next, coarse aggregate, particles size more than 4.75 millimeter. Next, geotechnical engineering. It mainly deals with the study of soil, its types of soil and their properties. Soil properties may changes from place to place, depth to depth, and even in the same place season to season. Any buildings, bridges, or dams and retaining wall, etc., consist of components like foundations. The foundation is laid from a certain depth below the ground surface till a hard layer is reached. The soil should be thoroughly checked for its suitability for construction purpose. The study dealing with the properties and behavior of soil under loads and changes in environmental conditions is called geotechnical engineering. Geotechnical engineering engineers analyze the soil to determine its suitability to support extreme loads. Proper geotechnical engineering is essential for safe and secure structure. Next, structural engineering. It deals with analysis and design of various structures like steel structures, treasures in industrial buildings, towers, etc. Concrete structures, buildings, bridges, dams, etc. Analysis, assessing or determining the internal force or stresses developed in structural components of any structures due to applied load is called as analysis. Next, designing, fixing or finding the suitable dimensions for structural components of any structures using various methods is called as design. Example, load acting on a structure is ultimately transferred to the ground or soil through beams, columns, foundation, etc. etc. When the load acts as the structure, the various components are subjected to internal stresses. Structural engineers design steel, concrete, or timber frame structures such as tall buildings and towers, bridges, dams, retaining walls, foundation, stadium. Next, construction planning and project management. Construction management, it deals with the different types of constructions of structures like buildings, roads, bridges, etc. Construction of underground tunnels using modern equipments. Construction of floating structures. Earlier days, only manpower is utilized for construction, but development of new technology, example, manufacturing of new machineries like cranes to lift the weight, painting machines, plastering machines, concrete or tar laying machines have made the construction easier and faster. Planning management, planning for the construction equipment and machinery for construction project. It deals with planning, scheduling, and execution of construction activity related to a project. Compromises of materials, time, and money management. Emphasis will be on new construction practice such as precast construction and pre-stress construction, safety of men and material utilization of marginal materials, etc. Next, hydraulics and water resources and irrigation engineering. And hydraulics, as we know that water is very important need for all the human beings. It mainly deals with the study of mechanics of water and its flow characteristics like pipe flows, open channel flows, dams, irrigation, hydropower, etc. Applications, determination of fluid properties such as density, vapor, pressure, etc. Design of hydropower, etc. Water resource and irrigation engineering. It deals with tapping or storage of water and supplying water to agricultural fields for crop cultivation and drinking purposes and to other domestic or industrial uses. Hence, suitable water resources are identified and it is stored. Identifying, planning, building water refining structure like dams, tanks, and carrying stored water to needy area is known as water resource engineering. Transportation engineering, it plays a very important role in economical development of country. It mainly deals with study of existing transportation system and their improvement for safe drive. It mainly includes design, construction, management of roads, railways, navigation, and air routes. The various modes of transportation are roadways, railways, airways, and waterways. Traffic management, including traffic signal, number of lanes, width of road, parking facilities, and curves are also a part of transportation engineering. Remote sensing and GIS. This is one of the new fields. The improvement in space technology, availability of GPS enhanced the scope of geographic information system. Good mapping technique helps to get required information accurately and quickly to effectively manage and monitor the available resources for optimal use. GIS is an high technique equivalent of map. It represents a means to locate ourselves in relation to world around us. It deals with the measurement, mapping, monitoring, and modeling of geographic information around us. Earthquake engineering. An earthquake is a sudden and rapid shaking of the ground due to passage of vibrations beneath caused by transient disturbance of elastic or gravitational equilibrium of rocks. The scientific study of earthquakes is called as seismology. Earthquakes are measured using observation from seismometers. Seismic waves are recorded on instruments called seismographs. The time, location, and magnitude of an earthquake can be determined from the data recorded by seismograph stations. Earthquake with magnitude of about 2 or less are usually called micro earthquakes are generally recorded only on local seismographs. Now let us see what are the types of building materials: brick, cement and mortar, plain concrete, reinforced and pre-stressed concrete, structural steel, construction chemicals. Let us see one by one. First, bricks. Bricks are obtained by molding clay in regular blocks of uniform size, and these blocks, as bricks are of uniform size, they can be properly arranged light in weight, and hence bricks replace stones. Classification: bricks can be broadly divided into two categories. One is unburnt or sun-dried bricks and burnt bricks. Unburnt or sun-dried bricks, these are sun-dried with the help of heat received from the sun after the process of molding. These bricks can only be used in construction of temporary and cheap structures. Such bricks should not be used at the places exposed to heavy rains. Next, burnt bricks. The bricks used in construction works are burnt bricks, and they are classified into following three categories: first class bricks, second class bricks, and third class bricks. Let us see cement. A cement is a binder, a substance used for construction that sets, hardens, and others toother materials to bind them together. Types of cement: ordinary Portland cement, which is commonly called as OPC. OPC, it is also known as ordinary Portland cement. It is a type of cement that is manufactured and used worldwide. OPC cement are available in three grades such as 33 grade, 43 grade, and 53 grade. Portland Pozzolana cement, PPC. It is prepared by grinding fly ash with Portland cement. It is also produced by adding pozzolana with the addition of gypsum or calcium sulfate, or by intimately and uniformly blending Portland cement and fine pozzolana. Port- Portland slag cement. It is a type of Portland cement obtained by mixing Portland cement, clinker, and gypsum with the granulated blast furnace slag in suitable proportions and grinding them into a through and intimate mixture. Grade of cement. The grade of cement is generally differentiated in terms of it indicates the strength of the cement. The strength of cement is generally measured as compressive strength. Compressive strength in the strength is the strength of cement molded in the standard cube after 28 days of curing. 33 grade cement. 33 grade cement means that the comprehensive strength of the cement after 28 days is 33 Newton per meter square when tested as per Indian standard under standard conditions. 43 grade cement. 43 grade cement means that the compressive strength of the cement after 28 is 43 per meter square millimeter square then tested as per Indian standards and under standard conditions. 53 grade cement. 53 grade cement means that the comprehensive strength of the cement after 28 days is 53 Newton per meter millimeter square when tested as per Indian standards under standard conditions. Next, let us see more about mortar. It is the mixture of cement, sand, and water. Uses of mortar. Mortar is used between the joints of the bricks during the construction of walls. It is also used to give a soft, even bed between different layers of bricks or stone masonry for equal distribution of pressure over the bed. It is used in plastering works to hide the joints and to improve appearance. Used in the manufacture of precast pipes, plant pots, and precast water tanks. It is used for molding and ornamental purpose. Concrete. Concrete is obtained by mixing cement, fine aggregate means sand, coarse aggregate nothing but as crushed stone, and water in a definite proportion. These are mainly classified into three types: plain cement concrete (PCC), reinforced cement concrete (RCC), pre-stressed concrete (PSC). Plain cement concrete (PCC). Plain cement concrete is a construction material composed of cement, fine aggregate nothing but as sand, and coarse aggregate mixed with water, which hardens with time. Reinforced cement concrete (RCC). Concrete has very high comprehensive strength, but It is low in tensile strength. Wherever tensile forces are involved, like in slabs and beams, it is recommended not to use plain concrete. So adding steel to the concrete is the solution. As we know, it has high tensile strength and also possesses good comprehensive strength. However, the bond between concrete and steel works well, and when these two are combined, called reinforced. After the alliance, the material is known as reinforced cement concrete. Pre-stressed concrete (PSC). Pre-stressed concrete is a system devised to provide sufficient pre-compression in the concrete beam by tensioned steel wires, cables, or rods that under working conditions the concrete has no tensile stresses, or the tensile stresses are so low that no visible cracking occurs. Types of pre-stressing. Pre-tensioning. In this method, the concrete is pre-stressed with tendons before it is placing in position. This method is developed due to bonding between the concrete and steel tendons. Pre-tensing is preferred when the structural element is small and easy to transport. In this method, similar pre-stressed members are prepared. Pre-tensioning members are produced in mold. Next, post-tensioning. In this method, pre-stressing is done after the concrete attains sufficient strength. This method is developed due to bearing. Post-tensing is preferred when the structural element is heavy. In this method, products are changed according to the structure. Cables are used in place of wires and jacks are used for stretching. Steel. Steel is an alloy of iron and carbon containing carbon from 0.25 to 1.25%. Steel is highly elastic, ductile, malleable, forgeable, and weldable. Types of steels: mild steel, tar steel, high tensile steel. Uses of steel as a structural material in structures, beams, and in the form of various sections. As a non-structural component for grills, windows, doors. It is used in the fabrications of steel pipes, tanks, etc. It is also used as a corrugated sheets which act as roof over the structure. Mild steel is used as a distribution steel and tar steel is used as a main steel in RCC. High tensile steel cable are used in pre-stressed concrete. Construction chemicals, adhesives. These are rich bonding properties apart from weatherproofing and waterproofing. They are widely used in all types of construction works, which include panel fixing, tile fixing, and floor covering. Sealants and coals. Sealant and coals are construction chemicals that are used to block an opening surface or small cracks to prevent liquid or gas or moisture leakage that can damage the construction. Epoxy grouts. These chemicals are used for grouting and has a high durability property and can be applied even in extremely high temperatures. These chemicals are quite expensive. Next, admixtures. Admixtures are used to modify the flow of characteristics, strength, and durability of concrete. Next, let us see the structural elements of a building: foundation, plinth, lintel, cheza, masonry walls, column, beam, slab, and staircase. First, foundation. It is the lowest part of building structure resting on soil below ground level. It is the first structural unit to be constructed for any building's construction. Let us see what are all the functions of foundation. It transfer all the loads of building through beam and column arrangement. It distribute the load evenly and safely to the ground. It also prevents settlement of the building. Let us see what are the types of foundation. Following are different types of foundations used in construction. First one, shallow foundation. Individual footing or isolated footing, combined footing, strip foundation, raft or mat foundation. And the next one is deep foundation, pile foundation, and drilled shafts are occasions. Next, plinth. The plinth is a part of foundation constructed either at or above the ground. Plinth is the offset created between ground level and the superstructure of the building. And the plinth is made by constructing a brick or stone wall or RCC beam from the ground level to the flooring level of the building. Plinth constructed by reinforced cement concrete beam is called as plinth beam. The main functions are it is used to prevent the entry of moisture from the ground surface to the building superstructure. It is used to take up the load of the wall coming over it. Next, lintel. Lintels are constructed above the wall openings like door, window, etc. Normally, lintels are constructed by reinforced cement concrete. In residential buildings, lintels can be either constructed from concrete or bricks or stone masonry. The main function of the lintel is to support the weight of the wall coming over the openings. Types of lintels: timber lintel, stone lintel, reinforced brick lintel, steel lintel, and RCC lintel. Next, chaja. It is a structure that is generally constructed above the window and projected outside from the window face. Chaja can also be provided above the doors. Chajas are constructed from reinforced cement concrete. Let us see the advantages of providing chaja. It protects the house from external sunlight. It protects the house by providing a barrier for sun rainwater to enter into the house. It can be used to place the compressor of AC. Chaja helps to protect the wooden windows from rain and sun. Chaja serves as an aesthetic decoration to the home. Masonry wall. Walls are vertical elements of buildings which supports the roof. They provide an enclosure and protect against windows, sunshine, rain, etc. Doors and windows openings are provided in the walls of ventilation and access to the building. It can be constructed using stones, bricks, concrete blocks, etc. Different types of bonds are used for constructing walls. The main function of masonry wall is to provide an enclosure and protect against wind, sunshine, rain, etc. The main components of masonry walls are masonry units like mud bricks, cement, concrete bricks, and hollow bricks. Masonry mortar. Mortar is used between the joints of the brick layers. Next, columns. Columns are the vertical members constructed above the ground level to support any structural frame. Load coming from the slab and beams are transferred to columns, and columns transfer the load to the footing safely. Columns can be divided into two types. Architectural columns, they are constructed to improve the building's aesthetics. Next, structural columns, they take the load coming from the slab above and transfers it safely to the foundation. Let us see the types of columns: rectangular or square columns, circular columns, short columns, long columns, axially loaded columns, column with the uniaxial eccentric loading, column with the biaxial eccentric loading, and composite columns. Slab. Slabs are constructed to provide flat surfaces, usually horizontal, in building floors, roofs, bridges, and other types of structures. The slab may be supported by walls or by reinforced concrete beams, usually cast monolithically with the slab, or by structural steel beams, or by columns, or by the ground. Types of slabs: one-way slab, two-way slabs, flat slabs, grid slabs, precast slabs, composite slabs, and hollow core slab. Beam. Beam is a horizontal structural member used to carry vertical load, shear load, and sometimes horizontal load. It is a major component of building structure. It mainly used in construction of bridges, treasures, and other structures which carry vertical load. Staircase. A staircase is a sequence of steps that connect different floors in the building structure. The space occupied by the stair is called as stairway. Stairs can be constructed by wood, steel, brick, or stone, or RCC, etc. The main function of staircase is to provide an access from one floor to another floor, to provide a safe means to travel between floors, to provide a suitable means of escape in case of fire. Types of stairs: straight stair, dog-legged stair, open navel stair, circular stair, and spiral stair. Thank you.